So what we have here is a product mix problem. We have been told that consider a small manufacturer making two products, A and B. Two resources, R1 and R2, are required to make these products. Each unit of product A requires 1 unit of resource 1, and product A also requires 3 units of resource 2. Now, for each unit of product B, it requires 1 unit of resource 1 and 2 units of resource 2. The manufacturer has 5 units of resource 1 and 12 units of resource 2 available. The manufacturer also makes a profit of rupees 6 per unit of product A sold and rupees 5 per unit of product B sold. So now they want us to formulate the linear programming function or problem. So now let us first of all try to summarize this information into a simplified format. So we have been told that we have products A and product B, and also we have resources we have R1, resource 1 and resource 2. So we have been told that product A requires 1 unit of resource 1, so we shall have 1 here, and 3 units of resource 2. And product B requires 1 unit of resource 1 and 2 units of resource 2. So we have products A and B and resource R1 and R2. Product A requires 1 unit of resource 1 and 3 units of resource 2, while product B requires 1 unit of resource 1 and 2 units of resource 2. But we have been told the manufacturer has 5 units of resource 1 in total. So the total resource 1 that is available is 5 and 12 units of resource 2 available. So the total available for the resources is 5 for R1 and 12 for R2. He goes ahead and tells us that the manufacturer makes a profit of rupees 6 per unit of product A sold. So that means that for every unit of product A sold, the profit made for this product A is 6 rupees, while he makes a profit of 5 units of rupees 5 units of product B sold. So for product B, the profit made for each unit of product B produced, he makes a profit of 5. So this is profit, and this is the total resources available. So now we have managed to summarize our information in such a way. So now the solution for that problem, we have to know the steps that we have to take to work out a linear programming problem. So the steps for problem formulation, so let's just list down the steps for problem formulation. If you are going to formulate a linear programming problem, these are the steps you have to take. Step 1 is you have to identify the decision variables. Identify the decision variables. Then step 2 is you have to write the objective function. Now step 3 is to write the constraints or limitations that are available. Constraints. Then the final step is to write the non-negativity restriction. Now, let's go through the steps very slowly or quickly. Step 1 is identify the decision variables. These are what the manufacturer has to consider. For example, in our case, what the manufacturer has to consider for product A and product B in order to maximize profit. How much of product A and how much of product B. Now, that means you have to come up with the variables that we need to work with in order to maximize the profit. Then number 2, we have to write the objective function. This is now like the target or the aim of the manufacturer. The aim of the manufacturer in this case is to maximize profit. So we have to write down that function. What is that function that the manufacturer has to use in order to maximize the profit? Then we have to write the constraints. These are in terms of, in this case, the resources. For resource 1, the manufacturer only has 5. And resource 2, what is available is 12. So we have to put in consideration those constraints, how much of R1 and R2 has to be produced for A, and how much of R1 and R2 has to be produced of B in order to maximize profits, something like that. Then writing the non-negativity restrictions. This is like the manufacturer cannot produce negative products. He cannot make he cannot produce negative product A and negative product B. It either has to be 0, like no production, or it has to be greater than 0, but it cannot be negative. That's why we have to state the non-negativity restriction. Now, let's first of all get our decision variables. So we shall let x be the number of units of product A produced, and let y be the number of units of product B produced. So x and y are our decision variables. So if the manufacturer produces x units of A and y units of B, then the profit that he makes will be profit Z will be, remember, we were told he makes a profit of 6 rupees per unit of product A produced, and we've said let x represent the number of units of A produced. So if there are x number of units of unit A produced times 6, since 6 is the the profit made per unit of x produced, so we shall have x times 6, which is 6x, plus he makes a profit of 5 rupees per product B sold, so plus 5 times y number of units of B produced. So that means our objective, or the manufacturer's objective, is to maximize profit. So the objective function is z is equals to 6x plus 5y. But remember, he wants to maximize the profit. So profit z is to be maximized. So we say maximize z equals to, so this is our objective function. We want to maximize profit, which is equals to 6 profit made from each unit from this X number of A produced plus 5 rupees times Y units of B produced. Ideally, the manufacturer would like to produce as much of A and as much of B as possible, but the availability of resources will restrict him from producing the amount or he wishes. So he has to follow the resources that are available. He has to put into consideration the amount of resources available. So since each unit of A requires one unit of resource 1 and each unit of B requires 1 unit of resource 1, the total amount of resource 1 required. So we've said that X represents unit of A produced. So if A requires 1 unit of R1, resource 1, so we shall have X plus also 1 unit of resource 2. Will have to be less than or equal to, so the total units of resource 1 available are 5. And also similarly, 1 unit of A requires 3 units of R2 and 1 unit of B requires 2 units of R2. So the requirement for X units of A and Y units of B is given by 3X plus 2Y should be less than or equal to 12, since we were told that the total for resource 2 available is 12 units. Yeah, so also we need to explicitly state that this manufacturer will make X and Y which are greater than or equal to 0. This means he cannot produce negative quantities of X and Y. So we say X and Y have to be greater than or equal to 0. Now, since the person, so he wants to maximize profit, and these are the constraints that he has. In summary, the profit associated with X units of product A and Y units of product B is 6X plus 5Y. The manufacturer will determine X and Y such that this function is maximized, since he wishes to maximize profit. The requirements of the two resources are X and Y for resource 1 and 3X and 2Y for resource 2. And the manufacturer has to ensure that these two are actually available. The resources are actually available. Then the problem is to find X and Y such that 6X plus 5Y is maximized. And X plus Y has to be less than or equal to 5 because that's what is available. And 3X plus 2Y has to be less than or equal to 12. So that only non-negative quantities are produced. So if we are to redefine the production quantities as, let us leave them as X and Y. So now, in summary, we have the objective function, which is maximize z is equals to 6x plus 5y, and the constraints are x plus y should be less than 5, 3x plus 2y should be less than or equal to 12, and also we state the non-negativity function, which is x, y should be greater than or equal to 0. So now we have been able to formulate our linear programming problem. Thank you so much. Don't forget to subscribe to the channel for more amazing videos. Bye.